So today, in this session, we're talking about heat loss and heat gain. So yeah, obviously I, designed this as best I could to, be valuable information for inspectors. Are there any builders in the room? One builder? Hiding in the back? Yeah, okay. And mostly inspectors, I imagine? Yeah, cool. On top of that, obviously, I have two goals for today. Number one is engagement. I love when we get a conversation going. We can always share knowledge, and that's always good. And number two, I don't want to be saying the word So if you catch me on that, let me know. Just got made fun of in the bathroom because I was saying it yesterday. So no ums. That's the goal. All right. Here we go. So this is kind of how the presentation is going to flow. A few different points here. First of all, what is required of mechanical contractors for a heating and cooling system design? What are you looking for? We're going to talk about the CSA F280-12. Does anybody know what that is? Okay.
Standard on measured piping design system.
Close. It's not about piping specifically. It's a calculation for heat loss and heat gain. Yeah. It's a CSA prescribed method. But yeah, we'll get into that. We offer a course at TECA teaching the heat loss and heat gain, how to use the software, and how to understand it all. We're going to talk about, briefly about what that offers. I want to talk to you a lot about the difference between heat loss and heat gain and energy modeling. Do people know what I'm talking about here? Do they know the distinction? Okay, good. I think that'll be very relevant. We're going to talk about EnerGuide rating system and step code and where those come into play. And then we'll do a quick review of the TECA software output, because I imagine and I hope that in the near future inspectors will be seeing this results, the heat loss, heat gain results output. So I just want to give you a little familiarity so that you know what you're reading when you come across one. Okay, so who cares? Yeah, honestly, who cares in the room about heat loss and heat gain? A couple hands, okay. Right on. No, saw some of that. Okay. So yeah, the relationships that I kind of want to talk about today too are between the builder and the mechanical contractor, and between the mechanical contractor and the inspector, and who's looking at what and where this comes into play. So how does the mechanical contractor decide what size of equipment to install? I imagine we'd all, have a bit of a guess or a vague understanding of it, right? They're going to do some math in the background to calculate the values, and then they're going to size the equipment according to that, right? The calculation methods used to be pretty simple. We've heard of things from, the finger method, where you stand on the driveway, look at the house, hold up a number of fingers. However many fingers you're holding up, that's the number of tons of heat you put into the house. I think that's out of date by now. There's the BTU per square foot method. And while these have been done, they no longer work, they no longer meet code. So we got to be done with that. Obviously today a lot more goes into it, right? We're doing a thorough takeoff of building plans. Literally every element that forms part of the envelope is getting considered. A ton of math goes into it, and a ton of data pulled from the region about outdoor temperature, indoor temperature, soil conditions, water table level. So where it's at today, if I wanted to sit down and do a heat loss, heat gain by hand, I can't anymore. That's over. That day is come and gone. So you need software now to do it. So for example, this gentleman calculates heat loss and heat gain for a house to be 55,000 BTUs for heating, 43,000 BTUs for cooling, for example. He needs to just choose equipment that can serve those loads, right? He needs to make sure whatever equipment he picks meets the load in the house. Anybody have any questions up to this point? I imagine this has all been pretty straightforward so far. So how do we calculate it though? Right? By what method do we calculate it? And that's what the BC Building Code tells us to do, right? They say you must calculate it with the CSA F280. And so that is a CSA document. It's a mathematical process. I said, yeah, that's one. Two, yeah. So the CSA F280 is a mathematical process as well as a couple pieces of software that determine, heat loss and heat gain of a building. So using the CSA F28012, I can calculate the heat loss and heat gain of a building. So if I go to the CSA website and I buy the CSA F28012 online, I think it's like $244. This is what I get. It's an 84-page PDF with a whole bunch of formula and data and tables. And kind of like a textbook almost. And then you get these tools as well. So remember how I was telling you that we can't do these calculations by hand anymore? That's where this comes into play. So we got some different tools here that use literally thousands of cells of calculations and iterations to produce values for below grade heat losses and infiltration heat losses. So this is just another visual representation of it. This is the CSA tools. This is what they look like if you buy it. This is for basement foundations. This is for slab on grade foundations. This is for air leakage. And yeah, and then you get a lot of formulas that look like that and a lot of data that looks like this. So yeah, for example here, I look at Vancouver City Hall. You guys probably can't read this, but you got everything from heating degree days, design heating dry bulb temperature, design cooling dry bulb temperature, standard temperature range, outdoor humidity ratio, wind speeds, temperatures for all the different months, latitude, longitude. So lots and lots of information is going on in the background here. The CSA F28012 is a big accuracy improvement on what's been done in the past. That is why there's a big push for all of this. I think probably everyone in the room has seen incorrectly sized equipment installed, furnaces or air conditioners, heat pumps, and that's why this is here. That's why there's so much push for this to be happening, to improve accuracy. And they do that with very intricate formula, calculation methods, and the software. If I told you that I have a house with an incorrectly sized furnace, what would you assume? It's oversized or undersized? Oversized, all the time, right? Why is that? Bigger's better, all right. Yeah, people are probably protecting themselves, right? Number one, the calculation methods themselves have some built-in safety factor, which, the less accurate they are, the more safety factor they want to build into it. And maybe people doing the calculations are building their own safety factors in. So you get all these things accumulating, and you get, way higher loads than are actual in the house. What was that? Right. Awesome point. We've got all these improvements in construction. He's talking about the thermal resistance of a wall or of a window, maybe even your air tightness as well, ventilation system. Everything's changed now. So the BTU per square foot method, amongst many other reasons, should not be used anymore. Yeah. Yeah, you have to actually consider what's in the house. Why bother putting better windows and better walls in if no one's been looking at that? Oh, so yeah. Why? Why do we care? Why don't I just say, this furnace will be at least big enough, just throw it in? Like, why do we spend all this time and complexity calculating it to try to get it really accurate? What's the problem with a furnace that's too big or an air conditioner that's too big? Inefficient? Okay, thank you. So, yeah, let's talk about furnace first. Inefficiency, yeah? You guys can just shout out.
The AC freezes up sometimes.
Awesome, yeah. So when you have an oversized, and actually this is one of the notes in the CSA F28012, but yeah, when you have an oversized cooling appliance, heat pump or air conditioner, when you get lots of that short cycling, right, you get freeze up of the coil. It can't condense it enough, right? Okay, anything else?
Client satisfaction?
What do you mean by that?
Making sure that they don't get a callback from a future owner.
Okay, okay. And a callback could come in the form of...
You tell me.
Yeah, well, yeah, no, for sure. Yeah, so callback with maybe they have a room that's not comfortable, right? Maybe it's hot and cold and hot and cold. Or maybe their appliance is, ready to go already after a short lifetime because it's not operating properly. Okay? There's another big one, which is just straight up money, right out of the gate. If you put in a way bigger appliance than you need, it just costs more money to install, ductwork, radiant, everything like that. So you can save money by doing a proper calculation. I think that's all the points I was looking for. The last one is when you do these calculations, you can look at some different models and compare them to each other and see how construction changes can improve your efficiency on the house, right? Maybe I spend a few extra $1,000s on windows, but I know that'll save me a lot of money on my initial install and monthly energy bills. So one thing for you as inspectors, if you have, actually, who has been looking at heat losses? Who has asked a contractor to provide their heat loss? 3, 4, 5. So yeah, we really hope that we're going to be seeing a lot more of that. It seems like all directions are saying that's where it's going to go, is to have that specifically inspected. What was that? No, you get an earful?
Oh, God, yeah.
Yeah. Where are you from?
The
Okay. Yeah. So one thing I just want to let you guys know, you are going to see smaller values for sure. Even on the back end when we were making our software and we started comparing results, we were like scratching our head like, really? That's low. I'm talking like half sometimes. Especially if you're using one of the guess methods, right? Like an estimate of BTUs per square foot. Compared to this, way lower than you might think. I had an energy advisor telling me that they had designed to put in a 70,000 BTU furnace, and the energy modeler came out with 26,000 BTUs, I think. And he brought this to the mechanical contractor's attention. The mechanical contractor said, "You're fucking out to lunch. 26,000, no way." Like that's how much difference they're seeing sometimes. So be aware of that, and it's okay so long as we're checking the actual methods, right? We're not tasking inspectors with reviewing the calculation methods. You just need proof that they were done. How would you do that? How would you confirm proper calculation was done? Yeah, exactly. Simple as that. Documentation. That's all you need. The results page, and somewhere in there it's going to say F280, whether you're using RightCAD, RightSoft, LoopCAD, or the TECA heat loss heat gain software. It says right on there it's built with the F280 calculation methods. And yeah, remember that's relevant because the BC building code tells us to do so. Questions? Comments? Jokes? Okay, where does TECA come in? We want to make it easier for contractors to do these things, right? We want to see better installs. That's really what this whole thing's about. We want to raise the quality of the industry. So we want to make it easy for people to comply with code. So what we have done is we've taken the CSA software, the formula, all the data, everything that makes up the calculation of CSA F28012, every little clause, every sentence, and we've made one Excel sheet. That is all you need. You open the Excel sheet, you fill it up. You don't need to know about your local temperatures. You don't need to know any of those things. It's all built into it. You just choose your region. You need to know all the information about the building. That's what you need to know. Where it's built, what the shielding is like, what the construction is like. So yeah, not that many of you will be using this, but I'll just show you really briefly what it looks like. So yeah, up here, like I just choose my location, right? British Columbia, North Vancouver. Right away, I get the heating degree days for that region, the climate zone, outdoor temperature values, outdoor soil temperature values. I define my indoor environment, right? The different temperatures of like conditioned spaces, basements, or crawl spaces. This is all customizable. Wind shielding, so this is like how much wind is batting down on your building, right? And how well your house is shielded. Humidity, so there's all these different inputs that look something like this. So the user would just go through the software, filling everything out about their building, save it out, and then that's your project. This is a little snapshot of how you define a foundation. So for example, this is a slab on grade. You define where the insulation is, what the insulation configuration is like, if you have insulation under the footings, soil conductivity, water table level. So it's quite detailed. Once you define the construction of the building, then you define the dimensions of it, like how much area of different walls and doors and windows and everything are exposed to the outdoors. Okay. This is, I think, where you're going to come in is on the results. This is what you'll be seeing. So every single project is printed out as 4 pages if you're doing a room-by-room load, or if you're doing a block load, it's 3 pages. The last 2 pages are just combined, is all. But yeah, basically how it looks is you got 1 page over here for input. So this is showing whoever's reading the report what went into the project. That's huge, right? Typically assumptions are required at this level all the way through. So you need to know what you're reading, or you need to know what these results are from. So this defines all the information about your building, and this is about the construction, like the R values of the walls and everything. And then you've got the results over here.
So when you're choosing your locations, is it, just the ones that are in the code, like the very general ones? Or
Yeah.
there's so many sub-areas that have different.
Yeah, great question. Thank you. There are like we took this whole list from CSA. That's all they've defined. What you would do, let's say you're searching for a region or city that's not on the list, you would choose the closest geographical city for latitude and longitude, and then you would input local conditions, right? The local temperatures of the air and soil if you have it. Yeah?
Sorry, this gentleman first.
Okay.
Just curious about the climate zones, because I'm in Coquitlam.
Okay.
We have climate zone 4 and 5. We determined this above a certain elevation. We have climate zone 5, and Coquitlam doesn't exist in the BC Building Code for environmental. It's just not in there. We have our own data.
Right.
But with this, are the people using the software able to change the climate zone? Or is it just geographically, because like I said, Coquitlam 4 and 5, but it's
Yeah, cool. So in the software, we just display climate zone for you. It's nothing's going on in the background with climate zone specifically. That's just if you need to look at your climate zone to look at what the code requires for code minimum, insulation values, for example. That's just for your information. If you're in one of these areas that you're talking about, that technically it's climate zone 4, but because of elevation it's climate zone 5, you would just have to input custom temperatures to best model your environment, and wind conditions on your building to best model the environment. Yeah. That is totally the responsibility of the user. We are not telling you anything about what your insulation has to be or should be. That's up to you. Yeah. So what you might be doing is maybe not you, but yeah, a contractor might have a builder they work for, and the builder's going to code minimum. So you look at the software here, the region. Oh, climate zone 5. You go to the BC Building Code. Code minimum for code minimum R values for windows, walls, doors. Everything comes from there. Does that answer your question? Okay. And lastly over here?
A couple of questions. The typical building official is a bit of a jackie of all trades. We are all things to all people at all times. So we love to be able to leverage other organizations as much as possible. In doing so, is there a place on this form that's like green if it passes, red if it doesn't, and a spot for the TECA seal? Like, can we as a building official rely on these forms to that extent and ease of review at all?
This is in the same way if you get output from another piece of software, LoopCAD or something, right? The onus is on the user. People can make mistakes in the software, and I don't know if it's not your responsibility to comb through it looking for these mistakes.
Right.
They provided it to you saying, I've done it by the proper methods. If something goes wrong and the blame starts to get passed around, that would fall onto the person who submitted it and made the error in the results. Do you want to elaborate on that?
I'm thinking of Tim's question, and I'm thinking if the inputs are correct, which would be something you could check pretty quickly, I would think, and correct me if I'm wrong, Chris, the output would have to be correct.
Yes.
So maybe the concern right now is if the inputs are correct, which would be relatively easy to check, and you get a BTUs at the bottom, and your inputs are good, then you can probably trust the output at the end, because that would be hard to fudge with the software.
Yes, in a way. Like all the building details, the location, what the walls and windows and everything are made out of, R values, that you can confirm really quickly, like you said. However, the dimensions of each element, we don't duplicate on the results. So maybe I have an extra 0 on a window, and it's creating a ton of heat loss, heat gain. I might not be able to see that.
But that would be showing, the window area would be on the input sheet, wouldn't it?
The window area is in the software only. It's not produced in the results.
Well, the input page would have the windows.
Yes.
So if the input was verified as being correct, could we not assume that the output would be correct?
100% yes. If you can verify the input, then the output is as CSA tells us to do exactly.
So maybe the only real concern then on the straight is that the input is correct, then you just circle the number at the end.
Yeah.
We're not going to go through on the channels. You basically do percentage of glazing to wall ratio or whatever. That's somebody else's job. So when we see this, we want to know that, basically from your perspective, not that kind of time.
Well, then that becomes a policy decision on TECA, as we've done with ventilation. We suspend certification, have done so where the checklists were fraudulently used. And whether we like it or not, we may be kicking and screaming into exactly that with this F2E as well. If it's fraudulently used and it's brought to our attention, we may have to use the same exercise. The legal answer to that question is that TECA, because we issued the certification, we have a legal right to rescind it. And that was the basis by which we suspended certification of a Surrey contractor doing work in New West that was not the standard. So maybe that's the administrative way of dealing with that. If you see something has been fraudulently used, just plain out to lunch, then contact us, and then I suspect that's where we will have to go as an association to support you.
So building on that, then, is this the outputs from this package, the software package, is there a spot for a TECA seal, and is it required to use this software?
Well, that was an identifying question, and it's maybe something we should build in.
So there is. I'll just show you. Yeah, I did put a place for a stamp here. However, at this point in time, it's just a placeholder. You can't see it, but very grayed out. It says not mandatory. So at this point in time, you're not demanding it. Someone can submit it to you without a stamp. That's fine. But we anticipate this might be coming down the road, so it's right there when we need to do it. Yeah.
Well, then we seek your advice, because at this moment, the software is for sale, and the attendance of the one-day course that Chris teaches is not mandatory. The software is literally sold on our website to anyone who walks in the door tonight. So then we have an administrative question. How would we issue a stamp when there is no, should I say, barriers to purchase? Mm-hmm. And that's an administrative question at the board level we have not pursued or thought through.
Yeah.
We seek advice.
Exactly. It's yeah.
When you're doing inputs of the wall insulation, say wall or ceiling, are you using the thermal resistance of the assembly, or are you saying that there's R20 in this wall?
Perfect. Yeah, I love your question. I'm going to get to it, but yeah, that's so relevant.
Right.
Yeah. So
That will affect the output.
I will say, if you have some sort of familiarity with how this results package looks, probably take you 10 minutes to understand what's going on. You could comb through in a couple minutes and have a pretty good idea if the person was diligent or not. You got every room listed by name here. someone who's whipping through and firing off things, they're probably not being detailed enough to choose all the right location information, shielding, everything like that, right? This is pretty thorough. And if they have all the rooms in here and you're seeing different values for walls and windows and everything in the rooms, they probably took their best swing at it. It's probably not negligence. If there's a mistake, it was probably accidental, I would assume at that point. Lastly, what you could do is you see the heat loss and heat gain values. You just kind of follow down, right? Heat loss looks really high. So then what you do is, okay, let's look at these different components. So down here, I'm not sure if you guys can see this, but walls and headers, windows, skylights, doors. My heat loss is really high. Let's look at this. Wow, windows is, times 10 what anything else is. That seems strange to me. Let's go down to the room by room and see if there's any room with a huge load for windows. And that's how you would kind of pinpoint maybe an error, right? Oh, look at that. This window is, got 20 times the heat loss of any other window in the building. That to me is a little bit strange. So then you might bring that to the attention of the user. It's pretty easy to spot where something went wrong with that method. First, you look at the heat loss. Is that okay? If it's not, you look at the overall different components of heat loss for the building. And then once you find something to look at there, you dive into it in the rooms. So, okay.
Hey, Chris.
Yeah.
Just a sort of out of the way question. On the water side, Thermalese was the main program for doing the heat loss. And now we're going to the CSA, as you're saying. Have you ever done a comparison between the two to see how different it is?
Thermal ease, not with thermal ease specifically, no. I think Steve Jollymore did, and I shouldn't comment on that because I don't remember exactly. But again, we did see a significantly lower value.
Significant?
Yeah.
Really?
Yeah.
Rob Polk did make that comparison. I don't remember the answer to your question.
Because I mean, that's the main one I would
Yeah.
in water sites. All the wholesalers use it.
Mm-hmm. We are, correct me if I'm not getting the terms right, Thermal Ease uses the hydronic software that still exists at TECA right now. That's the same software. Yeah, okay. So that hydronic software is still going to be available very soon here with this heat loss. So at the end of this heat loss, you can press a button that says Send to Hydronics Design, and then it opens up that exact same sheet that you're used to using. Well, maybe not you, but yeah. So on the hydronic side, that would look identical. So I just want to actually go through the results pages a little bit so you have some more familiarity with what they look like. Remember, there's 4 pages. Page 1 is what we're on right now. So anything here is very clear as soon as you just read it, right? Project details, okay. Who's the wholesaler? Who's the designer? Who's the contractor? So this is all the information that the user input, right? Environmental conditions. It tells you the city. It tells you the outdoor temperatures for heating, for cooling, and the soil temperatures. It also tells you the indoor temperatures of the building for heating and for cooling. Building floor area of all the rooms. Building volume, number of bedrooms. Active rooms, above grade height and highest ceiling. So these are all different inputs that the user made, and if you wanted to look at any specific one of them, you'd be able to look at the house and verify that fairly quickly. Infiltration, ventilation, and latent loads. Again, this is like, shielding of your building, right? Building site shielding, local wall shielding. So I've defined that. This is what this form looks like. Near the bottom here, we have some information on mechanical ventilation, on the heating and cooling system. Is it forced air? Is it radiant? And then at the very end, there is all the user information. So that's me, my company, my address, and then there's a place for a stamp here. But as we said, the stamp is not mandatory at this point in time. So that's page 1, all right? Page 2 is just one long table of all the different construction types in the building. So your wall types, how I defined those. Look up here. So I defined wall 1, and I just gave wall 1 an R value of 18.91. That's all I said about my wall type 1. So that's one of the walls in my building. Wall type 2 is, wood frames, stucco cladding, glass fiber bats, etc. To your question about what we're talking about when we're talking about insulation in the walls, I want to ask the audience, what is the difference between nominal thermal resistance and effective thermal resistance?
Effective takes into account all of the components used for that assembly.
Okay. So if you were to ask someone on site, what's the insulation of those walls? And they're like, the walls are R20. What are they probably talking about? Nominal, right? Which is the actual insulation value of the insulation only inside of the wall cavity. That's what nominal is, right? It's just talking about the insulation. But every element, every piece of that wall has some insulation value. So when we say effective thermal resistance, we're talking about every component mathematically added up together to give you the total R value of that assembly. Effective thermal resistance is all we care about on a mathematical level. Whenever we're seeing it from now on, like it's always effective. Whenever you see that in any sort of writing, it's effective they're talking about. The only time you hear nominal is maybe in discussion if someone's asking for it. All right? That's a big one, for sure. So I'll just let you know, too, in our software, we let people just input the R value directly. Like I said, I'm working for a builder. Builder needs code minimum. I know code minimum is 15.78 R in the wall effective, so I'll just type in 15.78. I'm done. That's all I need to do. Or maybe I just get a set of architectural or structural plans and I know what the walls are built out of, but I don't know the R value. I can input all the details of what this wall is made out of to the software, and the software will calculate the R value and display it. So here I've chosen wood frame, stucco cladding, glass fiber bats at 5.5 inch thickness, EPS type 1 at 1 inch thickness, 9.5 millimeter sheathing. So that's how I've defined my wall type, and the resulting R value is 22.7. And the exact same goes for ceilings and floors. And then down the page as well, you'll see foundations, and it just tells you what the foundation configuration is, if there's any insulation on the slab or on the foundation walls, and how much it is. So page 1 is about the building, where the building is, what the environment's like. Page 2 is about the construction of the building, the thermal resistance of the building. Yes?
Take into account slope ceilings.
Yeah, so slope ceilings is relevant for exposed area, right? That's what you mean? Like a cathedral ceiling?
Yes.
Yeah. So the difference there is going to be, like the R value would be very similar. We actually don't, in this software, worry about like heel heights in the compressed insulation on a sloped ceiling or on an attic. CSA doesn't go that intricate. But what we would do is, so we have the same amount of insulation, but the exposed area of that ceiling is going to be a lot more because it's on an angle. That's what gets accounted for. And in the building volume calculation, yes, you'd have to account for that too. Yeah. Yes?
So you said the program, when you enter the material, it calculates it for you?
Yes.
So let's just say you have a house that wants to put step on the front, but to save some money on the side house, they use vinyl side.
Yeah.
Would the program differentiate using two different types of cladding material?
Yeah, great question. So what we do in our program is we let you define 4 different types of walls for your building. And so I call them wall 1, wall 2, wall 3, wall 4. These are just codes we gave them. And when I'm defining a wall, like you said, on the left side of the house, I can choose that construction type to be either wall 1, wall 2, wall 3, wall 4. So we let you totally customize which wall is what type of construction within one room. Sorry. No, you can even go further than that. You could go within one room, one direction facing, but we don't need to go that deep into it. But yeah, does that answer your question? Do you understand what I'm saying?
Yeah, because you said that the effect of thermal, if you have 2 different
Yeah.
materials, it's going to change.
So on the front of my house, I have R20, but I know I can save a bit on the side by doing siding. I got R18, for example. When I define my room that has walls facing the front, I choose wall type 1 because I know wall type 1 is R20. But when I'm on the room facing the side, I choose wall type 2 because I know wall type 2 is R18. If we have time at the end, which we may, I can even show you the software a little bit, and you can see how that's done. Any other questions? I thought I saw a hand. No? Okay. So those 2 pages, there's no results on these 2 pages. It's just inputs. This is what went into the project. Page 3 is where results start. So this is heat loss. Page 3 is heat loss. Page 4 is heat gain. So for heat loss, we have 2 big things, right? Building heat loss and minimum required heating system capacity. So, hey, look at that. If my building is losing 23,646 BTUs of heat, I need to install a furnace that can provide at least 23,646 BTUs of heat or more. Make sense? And we also break it out in the different components for you: walls, windows, skylights, doors, exposed floors, ceilings, radiant elements, foundation, ductwork, radiant piping, infiltration, ventilation. So there's so many different components that add up to a heat loss. And further than that, even we go down to each room, and we break up each room to each different component. So the roof of the room, the wall of the room, floor, door, window, skylight, all the way over. And then the total value of the room on the right. You're also going to see at the top, registration number, purchased by, and company. This is locked on the software. The user has no control over it. When they activate their software, they're going to have a registration number. I think it's a 9-digit number. And then it should also have their name and company. And that's going to be on every set of results they ever submit with that software. So that's a good thing to glance at as well. Any questions?
Just looking at that heating tool. So on the old ones, they have the zones broken out. So wall, exposed floor, window.
Yeah, so heating and cooling zones is a step we don't take in this software. That would come in your heating system design phase. When you're doing the ductwork or the radiant layout, that's where you'd zone everything.
Okay. So that would still be part of the package that gets handed in.
Right. If you're also inspecting the ductwork, yes. Okay. Page 4. Were you in the... I recognize you. Were you in my thing yesterday?
Yeah.
Okay.
You were so good I had to come back.
Oh, hey, thank you. I was going to say, don't spoil this question, because no one knew it yesterday. I want to see if anyone knows today. So, heat gain. Remember, 23,646, that's heat loss. That's the heat loss in my building, so I need to install equipment that can provide exact same, 23,646. When I come to heat gain, I have, sensible heat gain of the building. I have a latent load multiplier and latent heat gain of the building. We'll talk about what that means in a second here. But I then have nominal system cooling capacity, 18,849. That's all the load in my building. That's the sensible load and the latent load. Minimum installed cooling system capacity is 15,079. So it's less. Oh my God. So he's seen me sell all of this before. Why? Why on earth would they say that the equipment I have to install for cooling doesn't have to meet the total cooling load? Nope. So the latent load and the sensible load are added together. That is your nominal system cooling capacity of 18,000. That's the total load of my house. But I only have to install equipment that can do 15,000. Any other attempts to answer this? Why for heating would it need to be the exact same, but for cooling it doesn't even need to be as big?
Because of where the sun is.
Were you in my thing yesterday? No. Okay, good. Right on. Exactly, right? If this is my house, you're looking at it from the street, my house looks like this. The sun is shining on this side of it, right? But as the sun moves across the sky, it's only ever loading from one direction. It's not in all places at all times, right? When I calculate my heat gain through windows and walls and everything, it's based on worst case scenario. If I've got an east-facing window, the load I calculate for that window is when the sun is coming from the east, shining right through it. But when I calculated my west-facing window, I did the same thing. I said when the sun is shining from the west, what load is hitting that window? So you're not going to be loading these two at the exact same time. Make sense? Yeah?
Maybe not going to answer, but does that change? Say we go further south, like Arizona, where the ambient temperature is higher. Does the effect of the sun have less of a deviation?
The way that's... So this is for Canada. This is Canada-wide.
Exactly.
So you're saying when we go outside of...
Yeah,
no,
I'm just
the way...
now, when it sounds like the sun has a fairly large impact on
Huge.
cooling load
Yeah.
here in the north. If
Yes.
we were to go south, does that hold true still, or from a science point of view, is it now the ambient temperature that overrides it?
I can't tell you the answer, but I can estimate that it would still hold true, because the way that would get accounted for is when I calculate heat loss and heat gain through that window, my latitude and my longitude, and like within the calculation for window heat gain, it's fairly complex. It considers latitude, longitude, everything like that. And so that is where it's going to be considered when I calculate the worst case scenario gain for that window. But the same dynamic is still going to happen. The sun is still only in one place at any given time. So what CSA says is, 80%-ish is how much of the total heating load you're going to need to meet at any one time. Sorry, the total cooling load. Okay? Any other questions? All right. So, latent load multiplier and building latent heat gain. What am I talking about there? What does that mean? Who can just tell me the difference between sensible and latent? Sensible heat and latent heat.
One has humidity. Something about that.
Yeah, you're on the right track.
That's all I know.
Okay, cool. So sensible heat is the temperature of air in a room. That's sensible heat, right? When I heat air up from 20 degrees to 50 degrees, that's a change in the sensible heat. I've added sensible heat to it. When I take ice at negative 10 degrees and I heat that block of ice up to 0 degrees, that's sensible heat because it's changing temperature. But then I have ice at 0 degrees, right? I have to keep adding heat to get that ice to slowly turn into water. I have to actually add a lot of heat to get that ice to go from ice at 0 degrees to water at 0 degrees. So even though I've added a ton of heat to it, the temperature hasn't changed. That is latent heat. And the reason that's relevant for us is because in the cooling season, our load is to take heat out of the air, right? We want to cool down the air. There's heat in the air that we want to remove. That's where our load is. The more heat in the air, the harder we have to work to remove all that heat. But there's also moisture in the air, right? Energy has been spent to turn that water into vapor. So it's sitting in the air as this energized piece of gas, basically. And as I lower the temperature of the air, I need to cool that little piece of gas to get it to turn into water. And when I turn it into water, it condenses. So I'm not trying to give you an intricate understanding of this, but all you need to know is that for the cooling season, our equipment is also tasked with a latent load to deal with humidity. So that's what we say a latent load multiplier is. Approximately 30% of your sensible load is, you add 30%, that's your latent load. Yes, David?
The answer I give for latent, which actually means invisible, is when you get off the plane in Phoenix and it's 100, it feels totally different than getting off the plane in Hawaii when it's 100. The difference is the moisture Chris is talking about, and that's latent. It's hidden, but it still hits you.
Yeah. That's how you feel it. Cool. Questions? So in the same way, I might look at my heat gain value and say, holy shit, that looks low. My heat loss was 50,000, my heat gain is 14,000. Like, what's going on there? Again, that doesn't tell you much other than something's wrong, so then you dive into each component, right? Oh, look at that. My windows are are nothing. There's nothing for heat gain in the windows, but I know there should be more than that. So let's ask them about that. This is how you kind of just investigate where things might have went wrong. So again, this is page 4. You have the registration information on the top right, heat gain for the building, all the different components of the building, and then room by room, component by component, all the way across. Internal, so what's going on here? Internal. For the basement, for the laundry room, it's 0. But for the family room, exercise room, and living room, it's 921. What's going on there? Anybody know? Nope. You might be thinking of like radiant heat coming through a window, adding heat to the room directly, not necessarily through the envelope. And that is a type of loading, but it's considered in the windows. It's considered an above grade element. Anyone else? Internal loads for cooling. We didn't see that for heating.
It's got to do with whether it's livable area or not. Are people in there, past ranges, like that.
Yep, you're completely right. So it's when we have things in the building that produce extra heat, right, that you also have to cool. So if I have a kitchen, building a house with a kitchen, that kitchen might have the stove operating, might have everybody sitting around the island and talking. So all these people, all these appliances are going to be producing heat. I still need to cool that room appropriately, so I need to consider those loads as well. What we say is you have occupiable rooms, like rooms that are fully occupiable, and not. Any fully occupiable rooms get a portion of this internal heat gain. Why was that not there for heating? So I consider internal heat gain for cooling, but not for heating. The people are still there, right? That's still going on in the building.
Those things are giving off heat.
Okay, they're giving off heat. So why don't I consider them for cooling? Sorry, for heating. Thank you. Yeah, I think you know the answer.
You're not losing heat.
Yeah. We're considering worst case scenario, right? I need to be able to cool this room at worst case scenario, which is when it's full of people and all the appliances are going and producing a ton of heat. I still need to cool that room. That's worst case scenario. Worst case scenario for heating, though, in the cooling, this is the cold season, the winter, right? If I have a whole bunch of people in the room and I'm operating the stove and everything, well, that's actually helping the mechanical system, right? Worst case scenario is when it's just me down there at 1 a.m. eating cereal. I still need to properly heat that room when there's no internal loads. So worst case scenario is when it's empty. That's why we consider internal loads for cooling, air conditioning, but not for heating. Okay. One last little overlook at the 4 results sheet. Does anybody have any questions about those? I hope you're somewhat familiar with how it might look, right? This is about the building, the environment, the mechanical systems in the building. This is about the envelope of the building, the walls, ceilings, floors, foundations, windows, doors, like the actual construction. Page 3 is heat loss, page 4 is heat gain. And if you're looking at a block load, page 3 and 4 are combined into one because you don't have the individual rooms listed out there. Question?
You're probably going to touch on it, but with this air tightness, I think a lot of these numbers are going to start changing on us.
Cool, I like your question. So let's go back up here. Let's talk about air tightness. We display air tightness for you. That is part of the calculation. I define the air tightness of my building, and my heat loss due to air leakage, right, changes appropriately. So infiltration, ventilation, and latent loads, that's the title of this section here. And very first thing I see is air tightness. It says present 3.57 air changes per hour at 50 pascals. Who knows what that means? Okay, so 3.57 air changes per hour means how many times the volume of my building, all that air, is changing in 1 hour. Okay, and what do I mean at 50 pascals? Pressure differential. Thank you, yeah. So this is when you actually have a certified energy advisor come to site, install a blower door, and what they do is with that, they impose a pressure differential on your building. And based on this 50 50 Pascal pressure differential, they calculate the amount of air changes per hour.
Chris,
Yeah.
presumably that number comes from the blower door test at the end. What do you recommend for an input at the start?
Great question. It is an assumption. When you're doing this to size the appliances, you would never have an air barrier up and blower door test results already. So this is something that you would, maybe you know the builder, you know approximately where they build to, and you would input something like that. If you don't know the builder, you might choose one of these preset values. So there's 4 preset air tightness levels. I think they are average, present, energy tight. Anyway, there's 4 of them, and they vary from like I think 10 air changes per hour down to 1.5 air changes per hour. And so the only thing we need to do here is there needs to be communication, right? If I do my entire heat loss to say this house is very, very, very airtight, whoever's building the house needs to know that, right? Otherwise, if they just build and away we go, hey, we need to make sure that this is actually met, or our values won't be accurate. So what might happen is I might know that the builder I work with builds to 2 air changes per hour. So I'll say, hey, for this project, I'll just confirm with him, you want me to go to 2 air changes? He'll say, yep, sounds good. So we'll do it. And then when it comes time to do the blower fan testing, they put the blower fan in with the certified energy advisor, and we're at 2.6, so that's too high. We need to bring it down to 2. So then what the energy advisor would do with the builder typically is walk around and you find these different locations of air leakage and you seal them up until you get that value down to where you need it. Does that answer your question, David?
Yes.
Okay, anything else?
When I was starting as a builder, I'd fudge and use a bigger number so my ass was covered.
Yeah. If we're covering asses, yes. You might, lots of times the builder will have a value they're going for, maybe for a certain step code level. Okay. Going once? Oh, yep.
Just another comment on that. I find it interesting that the temperature is in Fahrenheit, or it seems to be.
Yes. So it's the choice, right? If you look here on the results page, the user has the option to output the results in Imperial or metric. We're used to seeing BTUs, so we default to Imperial. If you want to see them in metric, it's as simple as one click of a drop-down, change to metric, print, done. Yeah. Yeah.
I just found that interesting. And all the other values in that table are in the BTUs.
Yes. Yeah, heat loss, and then in brackets, BTUs. Yeah. Yeah, like most of us, we're mostly Imperial, except for some specific things we're metric, and we don't mix back and forth. Yeah. Anyway, here we go. So yeah, back to TECA. What we do is we developed this software to do the calculation. We offer training for how to use this software, and to understand the inputs that are going into it. That's a big part of it. 2 people can sit down at a set of plans and do a heat loss for it and probably get different results. When I do a course with people, sometimes 15 people will have maybe a couple that have the same results, and it's because little things get missed, little like skylight shaft walls get missed here and there. So understanding the inputs is huge. What we envision in the future is, and I'm talking about the very near future, so I do my heat loss in the TECA software, and then I just click a button, send it to Hydronic System Design, the exact same software you've seen before if you've seen the TECA submission, and boom, now I'm in my hydronics design. And then also, we think that down the road we might also have another button you can click to send to a duct sizing program. And on we go with duct sizing. That would have to be a new software if we're linking the 2, but yeah. This is what we think could happen. Heat loss and heat gain versus energy modeling, what is the difference? Let's start with this. Who does heat loss and heat gain? Mechanical contractor. Who does energy modeling? Certified energy advisor. Right, okay. So the mechanical contractor is doing the heat loss and heat gain. Why? To size the equipment, to size the distribution system, right? The energy modeler is also doing a heat loss and heat gain. But we call it energy modeling, but that's what they're doing. Why are they doing it? For step code, is that what I heard? Yeah, okay, yeah. Yeah, so basically what we can say is, so we'll just go back here. Mechanical contractor, what they want to do is optimize the mechanical performance of the building and, you know, make it comfortable, make the indoor conditions right. It's about design. Their calculation forms the basis for design. The energy modeler, essentially it all comes down to just giving the building an energy efficiency rating. You might also say that it can be predictive of how much electricity you use in a year. You could say that, but that's not what it's for. It's to give the building a rating. They want this EnerGuide rating for the buildings, and it's to get everybody talking about the same thing. Yeah?
I use 2 words to help me understand this. The top is power. How much do I need for power in January to keep the house warm? The second one is how much energy am I going to gobble up over the 12 months? Mm-hmm. Power and energy.
Yeah. So, yeah, like the heat loss and heat gain is worst case scenario, and you just get a value. You just get a value of power. But the energy modeler also considers things like internal gains in the winter that will help you. So it actually tries to estimate how much energy you're going to use in a year, all things considered. And yeah, that modeling that they do gives the building a rating. This is why anyone would hire an energy advisor, because they want a rating for the building. And yeah, if you want to meet step code, you need to use an energy advisor because metrics from their output meet certain step code levels. So as I showed you before, these are the 4 pages from the Teka Output. This is the heat loss, heat gain software. This is so Hot 2000 is the energy modeling software. I'm sure some of you know that. I just grabbed a couple screenshots out of here because it's a massive report they print out. Yeah, it's got literally every area, every nook and cranny is on there, everything that went into it. So, yeah, I just took a couple, but that's kind of how it looks. So that's the difference between the two.
So this circles back a little bit, Chris, to what I was talking about earlier. BC government put out house performance reports for application documents for energy efficiency. So if we do or do not see a Hot 2000 report, that's at the local government level. But that house performance report comes in with the key summary pieces on it, the CEA's signature, and their certification number, if they're following the EnerGuide process. We can take that and run with it. It would be really neat to see TECA be able to bring the authority they have with their certification and their stamp to that same approach, where we can take that, TECA's on it, great. Here's the thing, it says green if it's good, red if it's not, we're done. So that we can have as light of a review as possible.
You're saying it would be great, I just want to make sure I understand you. It'd be great if this could also serve as that?
No, 2 separate things. I 100% agree we have 2 separate needs,
Okay.
2 separate purposes.
Okay.
But what I'm saying is the energy modeling on the right side comes with a cover sheet that we can look at, and within 30 seconds, ideally, be comfortable that they've done the job they need to do, and we've been able to recognize a delegated authority in that role. We'd love to be able to see the same thing from the TECA form.
Well, I don't know what would that look like?
Perhaps the software can spit out a cover sheet that the designer can sign, and maybe TECA requires a seal if they're going to be using the software. And it allows the building official to know, look at these.
Oh, I see what you're saying.
If they're green, great. If they're red, not great. If they're one bigger than the other, great. Kind of like the forms you already use for ventilation.
Okay.
I think what Tim is saying, that we have to sit down with Tech and maybe Tim and a few others of you and find out how to structure that. Because at the moment, our F280 was not structured to make that possible, but I can certainly hear your point and the need for us to do something like that.
Cool, yeah, noted.
We want to be able to use you guys to make our lives easier.
So just from our perspective, we have to pull a permit to do the heat. So we have to have a stamp, right? So when we get a heat loss, say for a radiant, it's got the guy's number on it and his Teka number on it and his signature.
And for forced air, we have the same process in place.
Right.
But the heat loss, which is one component of achieving that forced air radiant design, is the point in question at this moment that Tim is asking about.
Yeah, but if you take that heat loss and incorporate it into the whole thing,
Then you're covered.
then he's stamping the whole thing.
Good point.
Right?
Point.
Who,
Covered already.
right, and who would inspect that? Which inspector?
Well, in our municipality, it's the mechanical inspectors. Right?
Depends on the municipality, though, yeah.
Some like the regional districts, they have one inspector that's building, plumbing, a couple other things.
Okay.
Right? Some
That's
cities-
a good point.
Yeah.
We do have stamps and certification of both hydronics and
Yeah.
forced air.
Yeah.
So it actually, Tim's objective is in place.
Yeah, well, you were saying earlier that you just sell this thing and they don't have
The
to take
software,
the course,
yes.
right?
But
to actually be able to hand it in, they have to have taken the course and be certified and have their stamp.
for the forced air layout, for
Forced
the
air.
appliance selection and the layout, they have to have a stamp.
Yeah,
And you can ask for that.
Yeah, you can. But on the hydronics, definitely it has to come in stamped.
I think we're in place then.
Okay. Great points.
So this is one component of a heating system. The heat loss, heat gain, then you have to select the appliance, and then you have to lay it out, hydronically or air. But the last step, you have stamps on both the air and the hydronics side. Great. I think we're in place then. Great.
Cool.
You'll need the air noise because if you put the hydronics in, you're going to need the HRV, right?
That's completely separate, and we have an HRV course that's off the table for this particular discussion. The HRV is going to show up in the heat loss that calculation, yes, but the HRV course is a standalone, I believe, yes, that does have a stamp as well.
And that's for, installation of the entire HRV system, ductwork, everything.
That is in place.
Yeah.
It's only been 6 months, but it is in place now.
Cool. So I took a very simple house here, 2-floor house with a crawl space, and I ran it through both. I ran it through the TECA heat loss, heat gain software, and I also ran it through Hot 2000. So I just wanted to make sure we're in the same range, right? So for the TECA software, we got about 41,000 BTUs for heat loss, and for Hot 2000, I got about 37,000. So we're within 10% there. For heat gain, I got 26,000 BTUs for heat gain, and over on Hot 2000, I got 27,000 BTUs. So we're pretty close. So that gives me some assurance. We are using very, very similar calculation methods in the background. Lots of the CSA, like at least foundation configurations and wall assembly details are identical. Hot 2000 is a bit more intricate though. I would not expect to see identical results. So if you see differentiation, that's okay. You're going to. But if the heat loss, heat gain says 70,000 and energy modeling says 35, that's a different story. Now you need to have a conversation. I think this is really good news. I always used to think, until very recently, like, why don't they, like, we're doing 2 different heat losses. Why? Like, that's crazy. But I actually think it's a good kind of built-in quality check, right? I understand the different needs for both, and now we can compare them, right? If you get one that says 70 and one that says 30, now you got something to talk about. So I think it's actually a good quality check. What would you expect to see if I told you that, hey, I'm building this house, my mechanical contractor and energy advisor are off by double. Well, who do you think's higher? Who do you think's lower? What would you expect? Mechanical contractor is higher. Why would you say that?
Fear factor.
That's real. That's real.
Yeah. The mechanical contractor has this, impending fear of getting that phone call when it's cold in the winter and the heating system's not doing enough, right? That's where the caution comes into play. In every situation, if I don't have the exact details, whether it's envelope size or volume or whatever, and I'm sure this is everyone, we err on the higher side, right? But if they're doing the proper calculation methods, CSA calculation methods, then they should be pretty close. If they're not doing the calculation methods properly, the mechanical contractor is going to be way higher because they're using either old methods or they're just estimating because they look at a house and they know how big it is, they would say.
Or they're just changing the parameters that they're putting in. Like they might take the window to get more and make the window bigger. Right?
Yeah.
They can cover their ass, right?
Yeah. I would personally tell anyone who's taking my course not to safety factor that way. If you're going to safety factor with one thing, your indoor temperatures. That's it. And then that's right in your visible control. And people know that, right? They say, oh, I'm heating, I need to be able to heat this house up to 25 degrees. That's your safety factor there. Yep.
I find there's a real disconnect between mechanical contractors and energy modelers.
Yeah.
From the perspective of knowledge base. So you have a modeler that's basically then relying on a mechanical contractor equipment base. Is there any way to align those two that you guys have thought of that gives us a little better perspective on selection?
I think communication is huge. We got to put these two in touch. Yeah, David?
I think there's two things. The fear factor, I think, is a very big one. And with this heat loss, we're assuming that the distribution is so good that that small appliance is actually properly distributed uniformly according to heat load. And I show you in the next talk that isn't a very good assumption. So the question I was going to ask Steve is, what difference would you expect before you red flag it? You said
Steve or Chris?
Chris, what percent would you accept as being, say, a normal deviation, and what do you red flag? 20%?
Yeah. 10% fine, 15% fine. As soon as we start getting 20, 25, I might ask people to talk at least and see where this discrepancy is coming from.
Now, another possible explanation is that in forced air heating systems, the increments of BTUs on the appliances is like 20,000 or 30,000 steps, because they're built with one heat exchanger section, 2, 3, 4, and there's steps of 10 to 20,000 BTUs per steps. And the third factor is that the public today has certain expectations of pickup. We are not building in pickup for this. We're building steady state load at design conditions in January. To give you an example, I live in a 1952 shack in Burnaby. 1,000 up, 1,000 down. We had 100,000 BTUs oil, went to 100,000 BTUs gas. Now I get 50 gas in it, and it runs half time on design condition. So that shack went in with 100, but its load is 25.
Yeah.
That's the kind of stuff we're trying to correct. Because the analogy that I use when you're driving a car, if you have a 400 horsepower car, engine in a Volkswagen, you've got two positions for the throttle, wide open or nothing. It's a piss poor ride. But if you get something that's closer to load, even though you may forfeit a little bit of pickup, you're going to give a hell of a lot finer comfort in the shoulder seasons, which constitutes most of the heating season.
I don't disagree. I'm just trying to, like, when we see
But you're going to get this flat from the street.
we get it from the modeler, and then it's whose responsibility is it to ensure that the equipment that they're selecting, because they're the ones that actually are seeing the package, right? Go to the
Selection is on the contractor.
Yeah. Well, from the perspective for assurance aspect, we're saying, no, this is, the modeler has actually selected this and chose this pieces of equipment. They're signing off on it. And basically, we're going out and finding that actually it's not even close.
Sorry, I don't think a modeler would be selecting the equipment. They might tell the
Rating and
exactly. They're going to tell the contractor what parameters they have to hit.
no, I can tell you, we actually see it where they're selecting. And once they do that, then I'm expecting that that's what's coming.
Really?
I think that's putting the wrong horse in the cage.
I disagree. That's what I'm asking.
You're saying a certified energy advisor will literally go select the specific furnace you're installing.
Yes. That's putting the cart before the horse.
Oh, all the time.
All the time.
Okay,
The energy
good to
advisors
hear.
know what they're doing, but that one fits and makes my numbers work. But it comes down to educating the design team to talk to each other and the right people at the right time.
Mm-hmm.
So it's just a recommendation that there is a differential there.
Yeah.
And then we're saying who is really taking responsibility of the authority of this.
I think the final responsibility of that heating system has to be placed squarely on the sub that selected it and installed it. Because if he's a grant dealer, he sure as hell is not going to install Linux if he's a working contract.
Yeah.
You gotta ask who you're gonna, I'm just energy advisor, you're gonna ask what brand, or who's the mechanical engineer, what brands do they use?
Well, that goes back to Chris's comment about communication.
Yeah. The way I believe it should happen is rather than the certified energy advisor choose, and maybe they do, maybe they look at it, but that would at least have to get affirmed by the mechanical contractor because they're the one installing it, they're the one doing it.
I think that's why we're seeing that still the sphere factor that takes place. They're looking at the numbers to the perspective of what's
Yeah.
required. And they're like, well,
From the energy advisor, which are low.
right. And
Yeah.
they're back and saying, oh, no, you need this for this rate. It could be double.
Yeah.
Well, that's why he's saying that, you know, between the energy modeler and the mechanical engineer, we're looking at, if there's 30% difference, right? Okay.
Yeah. I think that
30% higher on the mechanical.
what we're looking for here is to catch installations like David said his house is, where you have a contractor that was thinking 100,000, but the energy modeler gets 25. Now you put those two in conversation, and you're going to learn the mechanical contractor did not do a heat loss. Once they do, if they've done it right, their value should be very similar. That's what we're trying to weed out with this. Cool. Anything else?
This whole issue of heat loss, we make it appear to be a precise science. Remember, it's an educated guess.
Yes.
Anyone who thinks it's better than that has no reality in their brain.
I agree. Yeah. Okay. So I made a little flow chart here. I got some feedback on it yesterday as well, but I just kind of want to talk about the relationship as I understand it right now, and you might be able to help me edit this. So you have, the builder. They're going to provide drawings, architectural drawings or structural drawings to the mechanical contractor and to the certified energy advisor, and they're going to say, go.
The EA is going to be involved long before the mechanical contractor.
Okay.
Long.
Thank you. So this is all, imagine this is back here. Yeah, so the mechanical contractor is doing mechanical design. The energy modeler is doing energy modeling. You're going to have the mechanical contractor, like the energy modeler needs the mechanical details, right? They need the mechanical drawings. It's part of their file. So this has to get submitted in one way or another. The way I understand it is there's a little bit of a dance that happens here because depending on the mechanical system, that can change the energy modeling, which can in turn change the mechanical details. This is what we're talking about when we're saying the energy modeler says, you need a 95% efficient furnace. That's this little dance that happens. Once the mechanical gets finalized, then at that point, that's where the energy modeling can continue. So we have what's called a P file, plan file, with final mechanical drawings. Once the air barrier is completed on the house, the energy advisor performs the final blower door test, and they can submit their end file. They need submitted final mechanical drawings to do that, and they need this air barrier test to be completed and successful in order to do that.
I think you've drawn a great best practice.
Okay.
But unfortunately,
But-
that's not where the reality is at right
Okay.
now. And that's okay.
What would reality look like?
You'll see the CEA ideally brought in at house design phase.
Okay, so they're going to be earlier.
Ideally.
Yeah.
Depending on how the local authority requires it, right? It might be that they submit and, oh, you need an EA, and there's a whole redesign process there. There is no mechanical drawings, and likely, unless we can get some like, as I say, shared authority and responsibility with TECA involved, it's kind of whatever mechanical contractor has the lowest bid, which typically means the simplest mechanical design that ends up in the building, which ideally the EA then tries to make reflect and make work in the energy report at the end of the day.
Mm-hmm.
Hopefully we're getting lower door tests prior to drywall.
Yeah.
See, that's huge, right? Because then you can make sure that that mechanical system is ordered based on that average.
Mm-hmm.
That system down below, that was for design for, say, 3.75 air changes per hour. If they're running at 5 or 6 in the house, we bring that down to meet that corridor test got to be before running.
Exactly. Yeah, there is one earlier as well.
Yes.
Yeah.
That's the most important one.
Okay. Tell me when.
Before you go, can you bring that slide up? I like that slide. Bring it so it's a little brighter for me.
Which slide?
The one we're looking at there. Just kind of
Yeah.
He's just modifying it.
Oh, okay. So I'm thinking from a building official point of view and a client and the discussion from an energy advisor, thank you, and a modeler back to the mechanical dude, you have to have a buy-in at a certain point with the client. Because who is the client going to call when the heating doesn't work and it's kind of like freezing here? Am I going to phone the energy advisor and say, hey, what the hell?
No, they're gone. They're long gone. It's the contractor.
Yeah, exactly. So I can see the fear factor being that point, like, I don't want that call back. I don't want to have that issue.
Mm-hmm.
So the client, I think the client has to be a bit of a buy-in on this science, if you will, because then as a client, I'm explained to me from the mechanical dude and the energy model dude, this is how it's
good point.
This is how I've come up with the system. And then I understand the theory, the science behind the fact. So if I'm freaking freezing cold in the wintertime, I have an idea what's going on and how to adjust the system. If I'm clueless, I'm going to phone the mechanical guy. The mechanical guy says, well, this is what I was told to do. Phone this guy. And it's just going to be a mad circle.
Yeah. You're saying there might be like even a bit of a standoff. The mechanical contractor saying, no, I'm not putting in a 30,000 BTU furnace here. And the energy advisor is saying, well, you got to do this and this and this. So you need someone to make the decision, which would be the builder or the homeowner. Yeah.
You have to have a client.
That's a good point.
Client buy-in.
Client buying. Cool. I like that. The mechanical contractor, if they do their calculations and they're very close to the certified energy advisor, 29,000 and 35,000 or whatever it is, the mechanical contractor still has the right to install a 50,000 BTU furnace, right? They still have that right. And it's just the efficiency of the furnace. No, it's the size too that goes into the energy model. Yeah.
As this energy step code comes in, it's going to be the whole exercise is going to be that.
Can you repeat the comment, please, Chris?
He said, as energy step code comes in more and more, it's going to get ugly out there.
The point that I would like to make in this next session is that in all these sessions where we're getting into better and better heat losses, which personally I totally support, the problem is that we're making an implied assumption which may be completely incorrect, and that is the 19,000 that Chris comes up with. We don't have any question about the validity of that if the house is built to plan. But we're making an assumption that that 19,000 is perfectly proportioned to the rooms in need according to the respective losses. In the case of an air distribution system, that is a wild-out assumption. That isn't the case in most design installed systems today. There's a huge increment of flow difference between using a 4-inch branch in Mrs. Smith's bedroom and a 5-inch and a 6-inch. There ain't no such thing as a 5.5-inch duct. We are not dampering any of these branch runs right now because you can't, because all the duct is boarded over. So it's left to Mrs. Smith to fine-tune with grills because that's the best we can offer. So be very, very careful if you're going to right size as the provincial and federal governments would advocate, because you've got to be cautious when you get that close to the margin.
It's an awesome point. Yeah. If I come out with a heat loss of 25,000 BTUs, I probably don't want to install a 28,000 BTU furnace. Cutting it a little close, right? Cool.
Does the system meet the building code as well? I mean,
In 933 right now, there is no upper limit to the capacity you install.
I know the building code is minimum.
It specifies a minimum capacity, but it does not put a ceiling on oversize.
So as I said, yeah, you got your CSA, your can have 280, sorry, is it? If you got a design to it and everything fairly meets the requirements of the building code, what more can you do?
Okay, so I get a call from I'm a contractor, let's say I get a call from someone and they are cold in the winter. Because of, let's say, exactly what David's suggesting is going on in the background. Bedroom's cold, living room's cold. But I did everything exactly as the code says, and CSA could come out here themselves and inspect my work, and it's perfect. What happens there? Do I just say to the homeowner, too bad, take it up with CSA? Yep, sweater on it, yeah.
Can I give a specific example? How many people have been in homes which are forced air in the main and baseboard upstairs? And why do you put baseboard upstairs? What's the technical rationale for using baseboard upstairs other than first cost? What's the technical rationale for putting baseboard upstairs and gas forced air in the main?
There's a separate.
They need rises, which of course is bullshit, hot air rises. What you may not know is as soon as you start building a house with floor door standard, the hot air will not rise because there's no escape for it, and you'll find that your whole top floor becomes underheated, which was discovered in the R2000 program 25 years ago, that we were short in the delivery to the second floor because we've been getting a free ride on shit leaky building practice for 30 years. We continued the same practice and we got burned with the top floor not heating. So this whole issue of distributions can become more important. There's no free ride on the second floor any longer. And it's even worse than cooling, because if you can't put the cooling system in the attic, and you're cooling from the basement, and you've got your biggest loads on the second floor, look out, Charlie Brown.
Yeah, awesome.
So,
Yes.
perhaps on that second page, that portion that it was talking about, the energy advisor should be signing off. Because I know the energy advisors, their biggest complaint is at the end of the project, the equipment they've spec'd is not put in. So if they have, if they're signing off on it, showing that they have communicated before it's actually installed.
Yeah.
That's a big one.
I think that would be a daunting task for us to take, is to get energy advisors required to sign off on our stuff. Is that what you're suggesting?
Well, maybe not that you require it, that the municipality require it.
I think we have a fundamental problem here. The energy modelers come from EnerCan background. They're proficient in the HUT 2000 program. They understand the enclosure of the building, the insulation, the draft roof, the windows, doors, and all that. By and large, with very few exceptions, they don't know squat about heating and cooling. I think what we have to do is we have to create a line in the sand where there's responsibility for the overall enclosure, and that has to be separated from the mechanical responsibility. If I was an energy modeler, what I'd want to know is I'd want to know the fuel and I'd want to know the efficiency with which it's used. Beyond that, I just don't care. Nor should I.
And I agree that that's the way it should be. It doesn't sound like maybe that's the way it is. But yeah, their role is to give the building a rating. That's it. That's what they've been hired to do, not to design mechanical systems.
State my own opinion. This is strictly what it is, but coming from a different province, we went through a lot of this with the energy efficiency guidelines. I started as an R2000 builder back in the 80s, so I've gone through a lot of this process, and now I see like similar pushback for the specific reasons why they created prescriptive
Cool.
So we're getting a lot of buy-in, but the floor door test is the only thing that satisfies the requirements to get the incentives, right? Which you're finding, your
Cool. Thanks.
There's two separate skill sets.
Yeah.
There's the enclosure and the mechanical. And yes, there must be, as you very correctly pointed out, some communication between, but they're two separate skill sets, and there should be two areas of responsibility. The loss is the enclosure guy. The gain, put the stuff back in, heat back in, that's mechanical.
Okay, guys, just a couple more slides I want to get through here. This one is relevant. In the CSA F28012, there are all these items for actual appliance selection. The heating system capacity must meet or exceed 100% of the value. The combined capacity of the heating distribution system must meet or exceed, on and on and on and on. Quite a few for cooling, actually. I just wanted to show you these because they are code requirements. However, you don't need to memorize them. The software user doesn't need to memorize them. We duplicate them for you right here. You can't read any of this, but these are all bullet points that say, the heating system must meet or exceed this. Cooling system must meet or exceed this, on and on. So what should happen is when I take my heat loss and do my appliance selection, I'm just going to look down here and I'm just going to say, yep, good, all the way through. That's typically what will happen. Okay, I think that's everything for me. Any last comments or questions? We got 1 minute. Yeah, I'm good. I'm good if you guys wanna go. That's good. Thanks so much.